Hi, physicists. We're going to talk about position, distance, and displacement. Here's Martha. Martha is standing at a location, and we can mark that location and call it 4. X equals 4. I like to think about position as a unique location in space. You can think about it like a number line, in this case, the x axis of a graph. Martha's at position 4. She could move. She could go to position x equals 9. If we call that initial position x subscript I, in her final position x subscript f, final position, then we could talk about her change in position. She moved from x initial 4 to x final 9. And that change in position is what we call displacement. And to talk about displacement, we use this symbol delta to mean the change in something. X was her location variable. Delta X means the change in her position. So to calculate delta X, we can do X final minus X initial. You'll see delta lots of things all throughout the year. Delta means the change in something, and it's always the final minus the initial. So in this case, delta X is the final position minus the initial position. But that means displacement can be negative because you might have, instead of moving to the right, moved to the left. And your final position might be a lower position, a lower number on the number line than your initial position. Here we started at xi equals 7. We finished at xf equals 2, which would give us a displacement of final minus initial, giving us negative 5, whatever the distance units are here. Okay, let's work through an example. Martha rides her bike 8 kilometers east, then 6 kilometers west, back the other direction, then finally 3 kilometers east again. Two parts to this question. What is Martha's displacement at the end of her trip? And what is Martha's total distance traveled? It's always a great strategy when you're problem solving to draw a picture. So here's my picture of Martha. I put her as X initial being 0. Here's the first part of her trip. She went 8 kilometers east. Then she's going to go 6 kilometers west, and finally 3 kilometers east again. You might be able to answer this question just by looking at this and calculating in your head. What is Martha's displacement? It's going to be 5 because she started at 0 and she ended at 5. What's the total distance she traveled? That's all 3 pieces added up. So 8 kilometers plus 6 kilometers plus 3 kilometers is going to be 17 kilometers. But really, when we're problem solving, we should write out the full guess method. That includes all of our givens, our unknowns, our equations, and then showing the steps of substituting into those equations. So for part A, what is Martha's displacement at the end of the trip? We need to have figured out that her final position is 5 if she started at position 0. The equation we're going to use, delta x, is x final minus x initial. That gives us the delta x displacement. Plugging into that, we get 5 minus 0, which gives us 5 kilometers. Don't forget your units. Part B of this, what is Martha's total distance traveled? This gets at the difference between displacement versus total distance. Her total distance was the sum of all of these stages of the trip. So if we add up 8 kilometers plus 6 kilometers plus 3 kilometers, we should get 17 kilometers. Summary: position is a location. We use the variable x typically to represent that location. Displacement is a change in position, which is always the final position minus the initial position. And lastly, distance is a length. It's always positive, and you can think of it like the absolute value of all the displacements along the way.